Good afternoon, students. Is my voice audible? Okay. So today we are going to discuss about Cayley-Hamilton theorem. So already we have discussed in the previous class, right? Isn't it? Okay, so what is Cayley-Hamilton theorem? So according to Cayley-Hamilton theorem, every square matrix, just wait. So according to Cayley-Hamilton theorem, so what is Cayley-Hamilton theorem? What is the statement of Cayley-Hamilton theorem? The Cayley-Hamilton theorem statement is every square matrix satisfies its own characteristic equation. Satisfies its own characteristic equation. So this is the statement of Cayley-Hamilton theorem. Okay. Yeah. Okay. So by using this Cayley-Hamilton theorem, what is the use of Cayley-Hamilton theorem? Anyone, can you tell me? Applications of Cayley-Hamilton theorem. So applications of Cayley-Hamilton theorem is to find the inverse of the matrix. By using Cayley-Hamilton theorem, we can find inverse of the matrix and yes, very good, Subhash and A8. All of you change your name as roll number, and also we can find higher powers. Okay, very good. Okay, so applications of Cayley-Hamilton theorem is applications. Just wait. Applications. So applications of Cayley-Hamilton theorem is, so by using Cayley-Hamilton theorem, we can find the inverse of the matrix. Okay, and also we can find higher powers of the matrix. Higher powers of a matrix. So these two are the applications of Cayley-Hamilton theorem. So what is Cayley-Hamilton theorem? So what is the definition of Cayley? What is the statement for Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. So what its own characteristic equation means what? So if we have a matrix like 1, 2, 2, 2, 1, 2, 2, 2, 3. So if we are having matrix like this, no, in that case, okay. So in that case, so we have to find the characteristic equation. How to find the characteristic equation? So that is based on this formula. Okay, so det of a minus lambda I equal to 0. So by using this equation, we can find the characteristic equation. So for suppose, if the characteristic equation is like lambda cube minus 6 lambda square plus some 11 lambda minus 6 equal to 0. So let us consider the equation will be like this. After finding this equation, the characteristic equation, if the equation is like lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. So in that case, so what is, we have to use Cayley-Hamilton theorem for verification. So what is Cayley-Hamilton theorem? The Cayley-Hamilton theorem is here, every square matrix satisfies its own characteristic equation. So what is the meaning of this? So the square matrix is this one, right? So the square matrix is A, and it satisfies its own characteristic equation. It satisfies its own characteristic equation. So means, so instead of lambda, we have to put A. Okay, so that is A cube minus, that means the given square matrix satisfies this equation, no? In that case, we have to put lambda, we have to put A instead of lambda. So that means A cube minus 6A square plus 11a minus 6 into, here we have constant, no? In that case, we have to put I. So that is equal to 0. So this is called as Cayley-Hamilton theorem verification. If we prove this equation, no, then you will get 0, no? In that case, we the verification of Cayley-Hamilton theorem is satisfied, or Cayley-Hamilton theorem is verified. Okay. So now coming to the first question. So all of you take the notes. Okay. So first problem is here. All of you take down the question. Verify Cayley-Hamilton theorem for the matrix A equal to, so the matrix is, so write down 3 by 3 matrix, that is 8 minus 8 2, 4 minus 3 minus 2, 3 minus 4 1. So this is our matrix. So now we need to verify the Cayley-Hamilton theorem. So what is the statement of Cayley-Hamilton theorem? Okay, no problem, no problem. We'll discuss. So once again, all of you listen carefully. So how to find the characteristic equation? The characteristic equation formula is det of A minus lambda I equal to 0. Okay, so the characteristic equation formula is det of A minus lambda I equal to 0. So by using this characteristic equation formula, we can find the characteristic equation for this particular matrix. Okay, so here A minus lambda I means for this particular matrix, the diagonal elements are 8 minus 8 3, right? 8 minus 3 1. 8 minus 3 1 are the diagonal elements. So for these diagonal elements, we need to put minus lambda, or we need to add minus lambda. So that means 8 minus lambda minus 8 2, 4 minus 3 minus lambda minus 2, 3 minus 4 1 minus lambda. So that is equal to 0. Okay. So how to find the characteristic equation? By using this determinant, we can find the characteristic equation. Huh? No, we have shortcut method. So the method is, see, that is, so this is 3 by 3 matrix, right? So for the 3 by 3 matrix, we have to use the shortcut method. So that is lambda cube minus lambda square into trace A. Lambda square into trace A. Trace A means sum of the diagonal elements. Trace A means sum of the diagonal elements. So that's why this will be 8 minus 3 plus 1. Okay. Plus lambda into, okay, so plus lambda into, here we have to do sum of the product of the diagonal elements minus sum of the product of the non-diagonal elements. Sum of the product of the diagonal elements minus sum of the product of the non-diagonal elements, right? So here the diagonal elements are 1 minus 3 1. Okay, so 1 into 3 8 into minus 3 and minus 3 into 1 and 1 into 8. Is it clear, all of you? So these are the diagonal elements. Here the diagonal elements are 8 minus 3 1, right? So here we need to multiply 8 into minus 3 and minus 3 into 1 and 1 into 8. So this is sum of the product of the diagonal elements. 8 into minus 3 plus minus 3 into 1 plus 1 into 8 minus non-diagonal elements. Here the non-diagonal elements are minus 8 4, 2, 3, minus 2, minus 4. So these are the non-diagonal elements. So here we have to do, this is sum of the product of the diagonal elements minus sum of the product of the non-diagonal elements. So for that we need to multiply minus 8 into 4. So these are the non-diagonal elements. Okay, minus 8 into 4 plus 2 into 3 plus minus 2 into minus 4. Minus 2 into minus 4. Isn't it? Next. So this is over, right? Lambda part is over. So next, what we have to do? Here we need to find the determinant. Okay. So minus of det A. So that will be 8 minus 8, 2, 4, minus 3, minus 2, 3, minus 4, 1. So here we need to calculate the determinant. Okay. So all of you solve this equation. Then tell me what is the characteristic equation. Do it fast. Okay, very good. Roll number 73. Lambda cube minus 6 lambda square minus lambda plus 22 equal to 0. So this is our characteristic equation. Here the determinant is 22 na minus 22. One. Okay. Okay, so this is the equation, right? So now what we have to do? So our next step is here by Cayley-Hamilton. Here we have to verify Cayley-Hamilton theorem, right? So by Cayley-Hamilton theorem, what is the statement? Here we need to write the Cayley-Hamilton theorem statement. So what is Cayley-Hamilton theorem statement? Cayley-Hamilton theorem states that Cayley-Hamilton theorem states that, so what is the statement? So for every problem we need to write this statement amount. Okay, so every square matrix satisfies its own characteristic equation. So this is the statement for Cayley-Hamilton theorem. Okay, so what is our next step? In the next step we need to verify Cayley-Hamilton theorem. Okay, so verification of Cayley-Hamilton theorem. Okay, so for verification, here we need to prove. Here we have to prove that. For this we have to prove that. What we have to prove? So we have to prove that this statement, right? So here the characteristic equation. Here we need the characteristic equation. The characteristic equation is lambda cube minus 6 lambda square minus lambda plus 22 equal to 0. Okay, instead of lambda, here we need to write a. So that is a cube minus 6a square minus a plus 22. Here we have constant, no? In that case, we need to put I here. Okay, so that is the equation. Okay, so here we need to prove this equation, that is a cube minus 6a square plus a plus 22 I equal to, we have to prove that is equal to 0. Okay, up to here, is it clear? Okay. Shall I erase? Okay. Good, good. So for verification, we have to take, take the equation. So what is the equation? Tell me. That is a cube minus 6a square minus a plus 22i. Okay. So for this we need a square. Already we have a, right? And what about I? So here a is 3 by 3 matrix, no? That's why we have to take identity matrix of order 3. So what is identity matrix of order 3? Identity matrix of order 3 means that is 1 0 0 0 1 0 0 0 1, isn't it? So now calculate a square and a cube. Do it fast and tell me what is the matrix. So first row is a square. For a square, this is 38. Very good. Roll number 73. 38 minus 48, 34. 14 minus 15, 12. 11 minus 16, 15. And what is a cube? Do it fast. All of you do with calculator. Very good. So a cube is here. A cube equal to, so that is 214 minus 296, 206. Very good, 84. Okay, so this is 88 minus 115, 70, 69 minus 100, 69. Okay, so this is a cube and this is a square. So we have to put a square and a cube and everything will be here. What is 5? A7. Okay, so you have to substitute a cube, a square and I values in the given equation. So that will be C. So a cube means 214 and minus 296, 206, 88. Okay. 88 minus 115, 70, 69 minus 100, 69. So this is a cube. Okay, so a cube and the next one is minus 6 into a square. So what is a square here? So a square means that is 38 minus 48, 34, 14 minus 15, 12, 11 minus 16, 15. Okay, minus a. So what is our given matrix? See, just wait. Our given matrix is 8 minus 8, 2, 4, minus 3, minus 2, 3, minus 4, 1. Okay, so this is A and 22 plus 22. Here we have plus 22i, right? So plus 22 into I. So this is equal to plus 22 into I. What is I? Identity matrix of order 3. So for that we need to write 1 0 0 0 1 0 0 0 1. Okay. So if you solve this one, no, you will get 0 0. That is null matrix. Here you will get null matrix. Otherwise you can check. So randomly you can choose first row, first element. First row, first element. In every matrix, you have to take first row, first element. So after solving this, you will get a null matrix. Okay. So once check and tell me whether it is correct or not. So that means zero matrix means this will be equal to zero. So from this, directly you can write therefore a cube minus 6a square minus a plus 22 I equal to 0. So therefore, so what we have done here, Cayley-Hamilton theorem verified. From this we can directly write Cayley-Hamilton theorem is verified. Okay, so like this we can verify the Cayley-Hamilton theorem. Okay, so now all of you find one question, that is C. All of you take this question. Verify Cayley-Hamilton theorem. Verify Cayley-Hamilton theorem. Cayley-Hamilton theorem and find the inverse of A equal to the matrix A equal to 3 by 3 matrix, that is 1 0 3 2 minus 1 minus 1 1 minus 1 1. Okay, now all of you find the equation, characteristic equation. Do it fast. Very good. Okay, okay, 73. So the characteristic equation is, so what is the formula for characteristic equation? That is det of a minus lambda I equal to 0. Okay, so that means for the diagonal elements, here the diagonal elements are 1 minus 1 1. So for the diagonal elements we need to add minus lambda. Okay, so 1 minus lambda 0 3 2 minus 1 minus lambda minus 1 1 minus 1 1 minus lambda. So that will be equal to 0. Okay, so now by using shortcut method we can find the characteristic equation, that is lambda cube minus lambda square into, what is the lambda square value? So here lambda square into trace A. Trace A means sum of the diagonal elements, isn't it? Trace A means sum of the diagonal elements. So here the diagonal elements are 1 minus 1 1. So sum of the diagonal elements, we have to add all the diagonal elements plus lambda into. Okay, so here for the lambda coefficient, here we need to write the sum of the product of the diagonal elements minus sum of the product of the non-diagonal elements, right? Sum of the product of the diagonal elements means here 1 into -1, -1 into 1, and 1 into 1. Okay, so that is 1 into -1 plus -1 into 1 plus 1 into 1. So this is sum of the product of the diagonal elements minus next non-diagonal elements. Here the non-diagonal elements are 1 0 3 1 minus 1 1, isn't it? So this will be 0 into 2 plus 3 into 1 and minus 1 into minus 1, minus 1 into minus 1. Okay, so this will be over. Okay, so minus determinant of the given matrix, the determinant of given matrix. So that will be det of 1 0 3 2 minus 1 minus 1 1 minus 1 1 equal to 0. So what is the characteristic equation? So det is -5. Very good. Minus into minus plus, that will be +5. Okay, so the equation is oh, very good. Roll number 73. Okay, so the equation is lambda cube minus lambda cube minus lambda square minus 5 lambda plus 5 equal to 0. Is this correct? Correct only, na? Just wait, I will mute you. Mute you. Yes, now tell me. Is it correct, Amma? Unmute yourself and tell me.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Okay. So what is our next step? First of all, we need to hear the question is verify Cayley-Hamilton theorem, right? So for the verification, so first we have to write the statement. So what is the statement of Cayley-Hamilton theorem? For every problem, you need to write the statement. Okay. So Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. Okay, so for the verification of this matrix, to verify Cayley-Hamilton theorem, so here we have to prove that so instead of lambda we need to put a, right? So and we have to prove that that will be equal to 0. So that is a cube minus a square minus 5 into a plus 5 into here we have constant now, that's why we need to put here I equal to 0. Okay, very good. So what is a cube? So for verification, we need to find a square and a cube by using calculator.
Minus lambda.
Very good. Yes, tell me what is a cube? Yes. A cube is 4 minus 3 21 9
Minus 8, 1.
1 5
minus 5
minus 5. Okay, very good. Roll number 73. and b1. Okay, tell me. What is a square?
4 minus 3, 6, ma'am.
Min
4 minus 3, 6.
minus 1, 2,
1, 2, 6,
2, 6.
and
the
0,
last
0,
one?
5, ma'am.
0,
0, 0, 5.
Okay, so for the verification, first we need to write the polynomial. So that is a cube and minus a square minus 5a plus 5y. Okay, so we have to prove that this will be is equal to 0. Okay, so what is a cube? That is 4 minus 3, 21. 9 minus 8, 1. 5 minus 5, 5. Okay, minus a square. So what is a square here? That is 4 minus 3, 6, minus 1, 2, 6, 0, 0, 5. Minus 5 into A. So what is our given matrix A? This is right. So that is 1, 0, 3, 2, 1. Sorry, 2 minus 1 minus 1, 1 minus 1, 1. Plus 5 into what is I here? Identity matrix of order 3. Isn't it? Because our given matrix is 3 by 3 matrix. So that's why we have to take identity matrix of order 3. So what is that?
1, 0, 0.
0, 1, 0, 0, 0, 1. Okay. So is this is equal to 0? A null matrix?
Yes, ma'am.
Yes. So whether it is equal to 0 or not, you have to write that will be 0, isn't it? Otherwise, you can check once. Okay. Randomly, you can check first elements. Okay. So this is 4. This is minus 4. Minus 5 plus 5. That will be 0. So that means this is equal to, the entire equation will be equal to 0. So therefore, so a cube minus a square minus 5a plus 5y is equal to 0. So Cayley Hamilton theorem is verified. So from this directly we can write Cayley Hamilton theorem is verified, or hence Cayley Hamilton theorem. So is the problem is over? No. So
Inverse, ma'am.
we need to calculate inverse of a matrix. So we need to calculate inverse of a matrix. How to find the inverse of the matrix? How to find the inverse of the matrix? Anyone?
Multiplying inverse on both.
Multiplying inverse on both sides.
We have to multiply
Inverse on both sides.
A inverse on both
Yes.
sides, right? So for that, first we need to take this equation. Okay. So shall I erase?
Yes, ma'am.
Okay. So can you tell me the equation? So that is a cube minus
Yes.
square
Minus 5a
plus
minus
Plus
5a
plus 5i.
5i equal to 0. So we have already we have this equation. So here we need to calculate, or we need to find A inverse, right? To find A inverse, we have to multiply with A inverse on both sides. First of all, you have to take this equation, that is a cube minus a square minus 5a plus 5i equal to 0. Okay. So first multiply with A inverse on both sides. So then that will be A square, sorry, A inverse of A cube minus A square minus 5A plus 5y is equal to A inverse of 0, that will be 0, isn't it? A inverse of 0 or A inverse of 0 is nothing but 0. Okay. So if I multiply A cube with A inverse, no, then this will be decrease. Or otherwise, you know that A inverse into A cube means A inverse plus 3. Okay, so A power minus 1 plus 3. So that means A square, isn't it? And also we know that so A inverse with A square, no, that will be A power minus 1 plus 2. That means we know that x power m into x power n is nothing but x power m plus n. So according to that formula, we can write like this. Okay, so A power minus 1 plus 2 means that is A power 1. Okay, so next one is A into A inverse or A inverse into A. So we know that A inverse into A is always equal to I. So if I multiply with I with A inverse, no, then that will be converted to A inverse. Okay, so substitute all these values here. So that is A into A cube means that is A square. So this is A square, sorry. So this is A square minus A minus 5 into I plus 5 into A inverse is equal to 0. Okay, so but we need A inverse, right? So for that A inverse equal to, so if I take these values to right side, no, so then that will be minus A square plus A plus 5i. Okay, so A inverse equal to, here we are multiplying with 5 now, then this will be here we have to write like this, 1 by 5 into minus A square. Okay, so what is A square? Already we have done in the verification now. So what is A square? A square.
4 minus 3, 6.
What is A square matrix?
4
Yes.
minus 3, 6.
4 minus 3, 6.
Minus 1, 2, 6.
Minus 1, 2, 6.
0, 0, 5.
0, 0,
5.
5. My plus A. What is our given matrix, Amma?
1 0 3
1, 0,
3
3.
2 minus 1 minus 1
Once again.
2 minus
Second
1
row,
minus
once again.
1.
So that is 1, 0, 3, 2 minus 1. Okay. So next, just wait. Plus 5 into I. Plus 5 into I. Identity matrix of order 3. So that is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So after solving this, you will get A inverse, right? But instead of doing all these values or instead of simplify all these values, directly you can do with calculator and you can write the answer here. Okay, so what is the answer?
2 by 5, 3 by 5 minus 3 by 5,
2 by
3 by
5,
5,
3 by 5 minus 3 by 5.
3 by 5,
Very good, A2. 3 by 5,
2 by 5,
2 by 5
minus 7 by 5,
minus 7 by 5,
1 by 5,
1 by 5
minus 1 by
minus
5,
1 by 5,
1 by
1
5.
by 5. So this is the answer. Okay, so answer will be, you can do with calculator and you can write here. Okay, okay, ma'am. Shall I erase? Shall I wipe off my screen?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, now coming to the next question. So all of you do this problem as a homework. Verify Cayley-Hamilton theorem. Verify Cayley-Hamilton theorem for the matrix. For the matrix, the matrix is A equal to 3, 4, 1, 2, 1, 6, minus 1, 4, 7. Okay, so 3, 4, 1, 216 minus 147. And also find A inverse. So this is the one application for Cayley-Hamilton theorem, and also we can find the powers of the matrix or higher powers of the matrix. So how to find the higher powers, A power 4 or A power 5, we will discuss in the next class. Any doubt?
No,
No, ma'am.
ma'am.
Okay, Amma. Thank you. Bye.
Thank you, ma'am.
Thank you, ma'am.
Tomorrow you have exam, no?
Yes, ma'am.
Rastunnara?
Yes, ma'am.
Yes.
How?
Online.
Online, ma'am.